Today's lecture is on delineation of formal, functional, and planning regions. We have already seen till now, we have already understood of what is a region and what are the types of region and what are the meaning of a formal region or a functional region or a planning region. So till this we are clear. But now let us see how can we delineate of each of these regions. Now, firstly, if we want to delineate a formal region, we all know what is the definition of a formal region. So, since you know what is the definition of a formal region, so when we delineate a formal region, we need to have some common characteristics. Here, there are some similar characteristics. So, according to the similar characteristics, we will group together. So, for delineation of formal region, this involves what the grouping together of some local units which have what character, similar characteristic, because similar characteristic is the basis of formal region. And according to certain defined characteristics, certain defined criteria, we will delineate each. What are the defined criteria? The defined criteria is that, for example, here you see subregion A and subregion B. So that means there are certain characteristics which are similar for subregion A, and that characteristic is not found in this subregion B. Similarly, vice versa. Subregion B characteristic is not found in subregion A. So these criteria, that is why it is written in the second point, these criteria, the criteria that were grouped together to delineate region A are not same for subregion B and vice versa. So what can be the criteria? You can see over here, some criteria are mentioned, that is unemployment rates, activity rate, etc. And as is obvious, it should differ significantly from outside the region. So if the unemployment rate over here is, for example, 30%, it should be anything other than 30%. There are certain variables which are used to delineate the formal region. So these are land use characteristics, demographic characteristics, transport, social service, etc. So these are the variables which are taken when we try to delineate a formal region. So we can delineate it based upon land use characteristic or demographic characteristic or various socio-economic structures, etc. So now let us see certain techniques. What are the techniques for delineation of formal region? Basically, there are two techniques. One is the single variable method and the second is the weighted index method. And in weighted index, we find fixed index, variable index and cluster method. Now in the single variable method, it is very easy. If we have a single criteria, for example, a hilly region is the criteria, then we delineate the regions based upon that single variable. What is a single variable? Hilly region. So all those regions which are hilly, we will delineate them into one formal region. Or for example, there is a single variable. In the previous slide, I had showed you certain variables. So if there are certain variables, for example, if we take transportation networks, so if we take that what are the nodes of transportation nodes, based upon transportation nodes, single variable, we delineate the regions wherever there are transportation nodes. So only one variable, if a region can be delineated based upon just one variable, that is called single variable method. But generally, you will not find regions which exist based upon just one variable. Generally, there are more than one variables. So for that comes these these methods. When the parameters or variables are more than one, then it is called the weighted index method, or we can find it out through the weighted index method. Now in a weighted index method, as I have said, that a number of characteristics which are common to region, those are chosen. And then those characteristics may be what? Those characteristics may be population or population density or per capita income or unemployment rate, rate of this industrialization, etc. So these are chosen and then our weight is given to each of these. If we are taking population, we will give a weight to this. If we take per capita income, we will give a weight to that. And then based upon that weight, what is done is that a single weighted mean is obtained for each of the region. And then based upon that, we group together into one region. Now, it might sound to you quite complex. So what I have done over here, I have tried to make, to show you practically how this is done. So in the weighted index number method, what we do, if we have more than one variable, if there is only one variable, there is no problem. We can just delineate the formal region based upon that one variable, whether it is hilly, whether it is maybe employment, whether it is population, we can easily delineate that. For example, we delineate highly populated regions. We delineate the least density region. These are the regions having least density. Or we delineate the monsoonal regions. There is only one variable. But what do we do if we have more than one variable? We do with weighted index number method. So over here, I have taken more than one variable, that is population and percentage of literates. And both of these two are correlatable because percentage of literates depends upon obviously population. It is not the percentage of literates of other than human. And over here, population refers to, of course, human. So these two are can be relatable. So here I have taken A to I, towns, cities, whatever, study areas. Now for this weighted index number method, what needs to be done is that, first of all, we need to give weights, and these are arbitrary weights. So it depends upon the researcher what weight he or she will be giving. So for giving that, what I have done or what is done is that the highest the population or the variable that has been taken, the value of the highest variable, that is 40,000. What is the lowest value of the variable? That is 15,000. So these two are added up. So when I add this up, this gives to 55,000. Now I want to make this, categorize it into three categories. So three categories, so I divide it by 3. That gives me this amount, that is 18,333. Now this value, to normalize this value, what I do, I make it a whole number as 18,000. That means all the population, this can be divided into 3 groups: less than 18,000, 18 to 36,000, and more than 36,000. So these are the 3 groups. Now I will give weights. So less than 18,000, I give them weight 1, because generally for a country like India, it is obviously preferable to have lower population. So I give them the weight of 1 for those less than 18. Now more than 18 to 36, I give the weight of 2, and of course more than 36, I give the weight of 3. Next comes percentage of literates. For here also, what I do, highest value plus lowest value, highest value plus lowest value is 119. But because the value is too less, so I decide that I will divide it by 2. I can also decide that I can divide it by 3. It depends upon the researcher. But I decide, because the value is not much more, so I will divide it by 2. So divided by 2 gives me 59.5. Again, I take a whole number, that is 60. Now that means less than 60, I should give some weight, and more than 60, I should give some weight. Now for literacy, if it is less than 60, that is not preferable. So what I do, less than 60, I give it 2, and more than 60 is preferable, so I give the weight of 1. You can give it vice versa also, then also it is okay, no problem. So that is how less than 60 is 2, less than 60 is 2, and more than 60 is 1, more than 60 is 1. Next, what I do is that, so this has been given. Now this is the study area. So this is the study area with A, B, C, D, E, F, I. So this is the study area. Now in the next slide, what I have done over here, I have simply input for A, what was the population, what was the literacy percentage according to the table over here. So I have simply put the values, nothing else. For each of these regions, I have simply put the values. In the next point, what I do is that I put the weights. The weights also, whatever I have obtained from the slide as given in weights. So simply, instead of doing anything, I have put the weights over here. Now in this slide, what I have done is that simply I have added those weights. So by adding those weights, I get these values. Now again, I need to understand that how will I delineate this? So what I do, highest value plus lowest value is 6. I want to delineate this into two categories. So 6 by 2 is 3. So I delineate the 3 and within 3 regions as one group. 3 and within 3 regions as one group. And this is the rough what it will look like, 3 and more than 3. So 3 and more than 3 and less than 3. So over here I delineate the 3 and less than 3 into one group. So that is what I have done over here. 3 and less than 3 has been delineated into one region, and the more than 3, that is 4, 4, 4, has been delineated into the other region. So this is how, so this is one formal region. This red thing is one formal region, and the rest is another region. So this is how a formal region is identified. And the cluster method is when we have to identify regions having different sets of parameters which cannot be grouped together. You can easily group together population and percentage literates because those two are based upon one variable, that is human. But you cannot group together oilseed production and mining or fishing, or oilseed production and number of banks. There is no correlation between mining or fishing and number of schools. There is no correlation between that. Or oilseed production or number of livestock. There is no correlation. But we have to group. Then how we can group? If you have to group, how we can group? Then we can group based upon the activities, because oilseed production, mining or fishing, livestock comes under primary activities. So we group all those regions based upon the primary activities. Regions having more dominance of maybe primary activities are grouped into one region. Region having more dominance of tertiary activities like number of banks, number of schools, these are tertiary activities, that is grouped into another region. So this is how the formal regions are analyzed, are delineated. So here what we are seeing is that in delineation of functional region, so there are three basic approaches. The first being flow analysis. So in flow analysis, as the name suggests, what we do is that we actually check for the intra-regional commuting flows. So in the intra-regional flows, what we do is that, what are the various types of flows? So the economic flows or the social flows, etc. So on the basis of the direction and the intensity of the flow, we delineate what is the functional region in that place. So here what I have taken certain places. So A, B, C, D and E. So 5 places I have taken. So these are all maybe regions, just these are regions. So from here you see from A to B to A to C, etc. So there is communication between each and every of these, between these various regions. And you can see here the thickness of the lines. The thickness of the lines are variable. Now these thickness of the lines are to scale. You can scale these lines. So maybe like 20 commuters, because we are generally dealing here with commuters. So maybe 20 commuters is equal to 1 centimeter. So if this is 1 centimeter in width, that means this represents 20 commuters. Now, if it is more than that, according to scale, we can easily identify how many commuters are moving from A to B. So from here, you can easily see one thing, that most of the thick arrows are towards B. So that means if it is towards B, so that means B over here in this entire region, B over here is the most important nodal region or the most important functional region. In gravitational analysis, what we do is that we see the gravitational pull between two places. Now we all know that the gravitational law of the theory of gravitational attraction was given by Newton. So for this we need some push and pull factor. So what are those factors? The factors are the mass of the centers and the distance between the centers. So if the mass of the centers, it is directly proportional to the mass of the centers. That means if the mass of the centers increases, that will also lead to increase between the gravitational attraction. That is, more people will be attracted to that center whose mass is more. And it is inversely related to the distance between the centers. So what is the distance between the centers? Means if the distance between the centers increases, then what will happen? Then the attraction will be less. That means there will be lesser people attracted to that center. So mass is represented by these. If these increases, these are directly proportional. And if this increases, that is, it is distance is by miles or by price or by intervening opportunities, then that will lead to less attraction to that particular place. Now, this is the model over here. This is the mathematical equation of that model. And for this model, now over here, you are seeing there are two regions. I have drawn two regions, region A and region B. See over here, the mass is more for B. How it is more? I have shown you in the previous slides. Maybe in this for B, the employment opportunities, etc., they are more, maybe. So that leads to its mass being more. So its area also becomes more. Now these till this region, and this region, the effect of A can be noticed. Since the effect of A can be noticed till this region, so a boundary has been made, and this is the boundary in which, according to this boundary, since its impact is till here, or till here, or till here, or people can easily, people staying in this periphery, in this zone over here, can easily be attracted, or they are attracted towards functional area A or towards nodal area A or to this city maybe. So this, according to the gravitation analysis, this is the boundary of A. Similarly, for B, since its mass is more, because its mass is more, so it can easily attract people from far off region. It can easily attract people from here till here, from here. So based upon what it can attract, based upon the distance, what it can attract, so this boundary has been drawn. But for A person living maybe here, but a person living over here, the distance is much more for that person to come all the way here. So that is a detrimental factor. So because the distance is increasing for a person living over here to come to A, that person will prefer to come to B. So that is why when distance increases, then gravitational attraction or pull also decreases. Now next we have, but over here in this region, this is a region of zero pull by both A and B. Neither this people living over here, this is maybe it is not good to either take the service of A or maybe B. Maybe people living over here, for them A is also very far away, B is also very far away. Maybe they will go to some other center over here, maybe center C. So over here, there is zero pull by A or B, or there is zero gravitational attraction for the people over here for A and B. So this is how the gravitational analysis it works. Now the next is the Thiessen polygon method. This is a very important method. Now in Thiessen polygon, what is done is, supposing this is the boundary of a region, a boundary of a region. Now we need to find out the functional areas in this boundary, in this region. So for finding out the functional areas, what we need to do is that first of all, we need to find out what are the various nodes. So these are the various nodes, or you can, in easy language, we can understand what are the various cities or the towns in that region, because a central place generally develops, or not central place, generally the functional region generally develops around a main city. So here are this is an imaginary boundary maybe, and here are three cities or towns or urban areas which has got certain functions. Now for Thiessen polygon method, first we need to identify this. So these has been identified. The next step what we do is that we connect these three. We are connecting. So this has been connected in the next step. In the third step, what is done is that, see, the middle point of each of these lines are delineated. So it has been delineated. This is the midpoint. So the midpoint has been delineated. Now, once the midpoint is delineated, then a perpendicular is drawn. Here, a perpendicular is drawn from each of these midpoints. So a perpendicular is drawn from between A to C, from the midpoint of A to C. A perpendicular is drawn through the midpoint of C and B, and a perpendicular is drawn between A and B, the midpoint through A and B. So of course these will meet somewhere. So it has met over here in this node over here. So maybe this node is termed as 0. Now what is done is that from 0, a straight line from 0 touching the node, touching the mid place, from this node to mid place is drawn to the ultimate boundary region. Similarly, from 0 touching the center place on C and B, a straight line is drawn over here. Maybe that is called B1 till this boundary. We can't go beyond this boundary because already we have taken this boundary. Similarly, from this 0, we take the midpoint of A and B and we draw a straight line. So we get over here three regions. What are the regions? C1, 0, B1, and this boundary. Similarly, B1, 0, A1, and this boundary. Similarly, 0, C1, boundary, A1. So we get over here three functional regions, which I told you. So this is the Thiessen polygon method. Next, we see how planning regions are delineated. So these are delineated basically based on what is the objective of demarcating them. Are we demarcating them based upon agricultural? That is our objective, to see what are the agricultural planning regions. We need to develop those regions. Or industrial planning regions, our main purpose is to develop the industries, or our main purpose is urban planning regions. We need to make various urban planning, etc. Or what is the basis of function? So the functions can be here, morphological function, etc., nodal root regions, etc. So these are the methods of delineation. What are the criteria? These are the criteria, basically divided into general, regional cohesion, and for planning convenience. Now, for planning regions, we generally divide it into qualitative and quantitative techniques. These are the two main divisions for delineating of planning regions. That is the qualitative technique and the quantitative technique. So for the qualitative technique, the regions are identified according to the development of the particular geographical regions, variables, and on the basis of the physical, economic, or socio-cultural variables, the boundaries are determined. Next is the quantitative technique. In quantitative technique, there are certain statistical and mathematical techniques which are involved. Now, the Thiessen polygon method, which I explained in the earlier slide, can also be applied over here. So I have already told you about that. Then comes the distance minimization, discrimination analysis, and the graph theory method. So these are the various other methods for this. So over here for the distance minimization method, we check how transportation cost between two centers can be minimized. And based upon the transportation cost and the distance, we delineate the regions. In the discrimination analysis method, this is more like the Thiessen polygons, more like that, not exactly that, more like the Thiessen polygons, where a boundary is determined, and based on that boundary which is determined, certain nodes are made, and based upon the nodes what we have, we make this model. In the graph theory method, this now utilizes the concept of the flow analysis while delineating the regional structure or the cities. So this is how the planning regions are delineated. Now this was all about the delineation of formal, functional, and the planning region.